Go.
Okay, we're going to take notes on scientific notation. Scientific notation is a way where you can write really, really large numbers or really, really small numbers that have a lot of digits in a more simplified format. So if we start with the number 36 million, the first rule is to move the decimal to create a number between 1 and 10. And then we're going to drop any insignificant
It's good.
zeros.
This is really
So, on the number 36 million, our decimal is already back here. It's hiding out at the end back here. And we're going to move it to between the 3 and the 6. And so 3.6, when we move it from here to here, we're moving it 1, 2, 3, 4, 5, 6, 7 times. And we've created a number that's between 1 and 10. 3.6 is between 1 and 10. If we had put the decimal after the 6, that is not that would be 36, which is not between 1 and 10. And if we had put it in front of the 3, that would be 0.36, and that's also not between 1 and 10, that's too small. Alright, so the second step is to then write times 10 with an exponent that equals how many spaces you moved the decimal. So we have 3.6, and now we're going to write times 10, and we're going to count how many places we moved it. We moved it 1, 2, 3, 4, 5, 6, 7. And so that becomes the exponent on your 7 there. And if you look at this poster over here on the wall, you can see that the bottom row there has 10 to the power of 7. If you look there, you can see that that equals 10 millions. And then if you look back up here at the screen, good. Okay, if you look back up here at the screen, if this represents 10 millions, if we took 3.6 and multiplied it by 10 million, then we would be back at our original number. Now, this format, this whole thing right here is called scientific notation. And this format that we had way up here at our original number is called standard forms. Okay, let's look at a couple of examples. We're almost done. A couple of examples. 7,230,000,000. So we would make it 7.23, creating a number between 1 and 10, times 10, and we're going to count how many places we move the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9. Moved it 9 places. Okay? And then finally, sometimes we might have numbers that are really, really small. Let's write 5 zeros, 1, 2, 3, 4, 5, and then a 4 and an 8. So this would represent something really microscopic, really small amount. Same rules apply. We're going to put 4.8. That creates a number between 1 and 10. And then we put our times 10. And we're going to count how many places we move the decimal point. 1, 2, 3, 4, 5, 6. Except this time we're going to put a negative on our exponent. So it's 10 to the negative 6. Okay? And then finally, I just want you guys to remember that big numbers, large, big numbers that you wish someone would write you a check for that amount of money, those go with positive exponents. And little teeny tiny microscopic numbers always go with negative exponents. Okay? And that is scientific notation.
Yay!
Yeah, but